So now we'll move on to a topic that can have the most difficult questions, circles. And specifically we're talking about circles on the graph. So let's think about what a circle actually is. A circle is defined as the locus of points equidistant to a single point. And so a locus means a set of points that meet a certain criteria. Or meet certain criteria. And for this one it's saying of points equidistant to a single point. So it's saying we've got a single point here, and if we're saying it's the distance r, we're saying every one that has a single r. And you know how you get your compass? You set it to a certain length, push down the sharp bit into the page, and then do and then you just rotate it. You're keeping the same distance around, and that's how it's a locus, and you're just taking every point, and when you take every point, you get a continuous line. Well, in this case, it's not a line, but a continuous circle, and that's what a circle is. And so let's use this definition to see if we can get a bit of a formula on the graph. And let's say we've got this center here, and we're trying to figure out an equation for it, and specifically a way to express any point on this circle. So let's take the case here, up here. Now, it may be difficult for you to imagine this, but so I'm just going to jump in straight in to drawing this, a right-angled triangle. This here is R, the radius, and let's call this, I don't know, M and N. We would know that M squared plus N squared equals R squared. And if you rotate this around, you're just doing essentially just for any M and N. So we can use this as a way to express any points that satisfy M squared plus N squared equals R squared is going to be our circle, right? And what specific is this R squared? That way, that's making sure it's a locus of a distance. Now, the second part is the locus from a point. So how do we make clear the point? Because if we did a different circle, we could call it M and N as well, but it's different. So how do we make that difference clear? Well, think about if I rub out some of this. Think about how we would get M and N. And if you remember how we derived the distance formula, we'll call this x, y, and the centre a, b. We pull this down, we get x and a. And if we pull this across, we get y and b. What's this distance m then? Well, m would just equal x minus a. And then n would just equal y minus b, right? So now we've got this thing, x minus a squared plus y minus b squared equals r squared, where a, b is the centre, and that's the point from which all the points on the circle is equidistant from, and r is the radius, and that's the equidistant distance. And so that is the equation for a circle. Now, it could look something like this. So, for example, if you had x minus 4 squared plus y plus 5 squared equals 81, then what you could say is this circle has a centre 4, negative 5 and a radius of 9. But that's not the only way we could write a circle equation. We could also write it like this. Oh, it doesn't look great, does it? And if it asks you to find the centre and the radius there, then that may be a bit difficult. So here is what you would do. X squared, rearrange it to just collect the like terms. And I would put the constant on the other side. It would make it probably a bit easier. And then what you do is you complete the square. You'll find in AS that you'll have to complete the square a lot. And I mean a lot. So, yes, get up for it, get fizzed, and get over it. And just remember what I'm doing. I'm halving this, I'm squaring that, and then I'm minusing the squared thing. So now, if we then get our constants, the other side, so 25 plus 16 is 41, so that's 81. And somehow this has been completely random. I've managed to get the same radius, but an opposite point in a way. So, because that centre will be at minus 5, 4, and that'll have a radius of 81. Interesting. That was completely spontaneous. And so that's how you can complete that square. And if we look at what this actually will be and think about how we just halve this, and that would give us our thing in the bracket. So we could say that that's actually x squared plus y squared plus 2ax plus 2by plus c equals 0. Because we've halved that to give us our b thing in there. And then that would mean our centre would be at minus a minus b. And if we think about what our centre will be, it'll actually be, because we've taken this, we've halved it, then we square it. So a squared, and remember we minus, well, you get just add it to the other side. So then you get the b squared part. And then because we've taken this and we've minused the c from both sides, we've minused a negative, meaning we've added it to the other side, so that's minus c. Square root that, and that's the radius. Now that's fairly easy. Going from equation to centre and radius, very simple. But going from some information to an equation for a circle, now that can be a different story. Obviously, if it said centre of 6 minus 3, radius 36, that's very easy. Oh, sorry, let's go radius 6, very easy. You'd just be going, x minus 6 squared plus y plus 3 squared equals 36. Easy. Centre and radius, that's so free. And it's so free that you probably won't get it in an exam. And then another way they could do it is doing centre and a point. And what you could do is, well, you want to end up getting these things. you want to essentially end up with the centre and the radius, because those are what defines a circle, right? Yeah. And so we can use the centre and the point to get, we have the centre, we just need to use it to get the radius. And isn't the radius defined as like the distance between centre and anything on the circumference? So we could just do a distance formula. So let's say it's got a centre 5 minus 3. It may not be nice numbers. It's the centre, and then a point on the circle is 10, 9. So we do a distance equals 10 minus 5 squared plus 9 minus 3 squared. So that's square root of 25 plus 144. What a miracle. I can't believe I managed to get a perfect square on the fly there. So it's and I'll change that to R. It's 13. It doesn't matter because you square it in the end anyway, but still. And then so you get x minus 5 squared plus y plus 3 squared equals 169. So that's centre and a point, also quite easy. Another fairly free way would be when you're given 3 points on the circle. If you take the 3 points, say a circle goes through -1, 4, 1, 6, and 5, 4, we're going to use a geometry principle known as, well, in a circle, that's an oval. Quick shape did not, failed me there. If you have 2 points and you draw a line through them, this is called a chord. And if you think of it, you could be perpendicular, you could make it a tangent if you just slide it along, which should make sense that it will be its perpendicular bisector will pass through the centre. And if you had another one, then because that one will also go through the centre, they will meet, those bisectors will meet at the centre. So we can use that fact for this one. We should first, we'll call this P, Q, and R, and let's first work on P and Q. I'd first work with M of PQ, the gradient. 6 minus 4 over 1 plus 1, that's minus 1, equals 1. And then that means the M of the perpendicular bisector is minus 1, divided by 1 if you want to be pedantic. And then I would say midpoint PQ is equal to minus 1 plus 1 over 2, 4 plus 6 over 2, which is 0, 5. And then we apply y minus y1 equals mx minus x1. And that would be y minus 5 equals minus x minus 0. That's minus x, so y equals minus x plus 5. And then we'd do the same for Q and R, maybe, or P and R, that would work as well, but we'll work on Q and R. Four minus 6 over 5 minus 1, so that's minus 2 over 4, which is minus 1 half. And then so the perpendicular gradient will be minus 1 divided by minus 1 half, which is equal to 2. And then the midpoint of QR is 1 plus 5 over 2, 6 plus 4 over 2. So that's 3 and that's 5. And if we do y minus y1 equals mx minus x1, get y minus 5 equals 2x minus 3 equals 2x minus 6, and then that's y equals 2x minus 1. And now we will find their intersections. We'll do simultaneous equations. So we found out our x-coordinate of the centre. Now we substitute this back in. And that's equal to 3. So then that would be 2, 3. And now we just would do a distance formula. So r is equal to, say, let's do 4, we're doing r, point r, minus 3 squared, plus 5 minus 2 squared. That's 1 squared plus 3 squared, which is 9. So that's root 10. So then the equation is x minus 2 squared plus y minus 3 squared equals 10. Still quite easy. Now we might be getting into something that may be a bit difficult. For example, a point and a line passing through the centre. So let's take the point, let's say the circle goes through this point and the centre lies on x plus 2. How we would work this out is we think of our general equation and think, okay, recognise that we have an x value of a point on a line and we have a y value. So we could rewrite this as that. And we also will need the radius. So let's say this has a radius of 5. And so then we'd write 11. So after writing that, we would say, then it goes, because it goes through the point. Oh, sorry. That needs to be x. So we'll do the x there and then the y here. So that's 4 minus 4a plus a squared plus 81 minus 18a plus a squared equals 25. So that becomes 2a squared, and that's minus 22a plus 60, because a, that's 85, and then get rid of that. A plus equals 0. And that leads to a minus 5, a minus 6 equals 0. So you have two possibilities, a equals 5 or a equals 6. And so that means b equals 5 plus 2 or 6 plus 2, which is 7 or it's 8. Therefore, you can get two possible equations from this information, by the way. X minus 5 squared plus y minus 7 squared equals 25, or x minus 6 squared plus y minus 8 squared equals 25. Now, given sufficient, and from this, and using sort of this kind of theory, you can also get the equation from 2 points. If it's a diameter, it's easy. You would just go midpoint for centre, half distance for radius. Easy. And then if it's non-diameter, need radius, you would perpendicular bisector. This is a line through centre. So you could go up and do this. Same thing again. You need the radius here as well. So those are the different ways you can find the equation of a circle. And generally, remember that the whole aim is to find the centre and the radius. And from there, you can get the equation. And you may have to get creative. Be prepared to get creative. So yes, next time we will go through more of the geometry of the circles rather than just the algebra. There'll be some more use of the geometric properties in the next video.